Okay, I think I'm live. Hopefully you can hear me. Oh, totally unprepared. I had a book. So you can see this is pretty casual. I'm a little early. I like to be punctual. I also like to make lists. So for this AMA live chat, just a couple things. There's no comments. I'm not going to read the comments in the live chat, and I turn chat off on the video. So if you want to respond to anything I'm saying, go to the Reddit link in the description. That's the interface for anybody to interact with me, because I'll be reading those. This is basically just me talking about what I don't have time to write as I'm answering these questions. If anyone comes here later, they can listen through. It's just more media. I like more media when I can, and this is like free and easy. So this may be really boring. So it's not to be entertaining. It's more to be a reference. So there may be long periods of me thinking, typing, etc. I'm going to take breaks too. So anyway, let me start off with this first question here. Let's do, or I could do the original questions. Okay, so let me start off with a list of original questions. Currently listed. I just have to go there. It's going to be so boring. I'm sorry. But I am going to get the questions here. Just going to look at my messages. Okay, I'm going to answer some basic questions about me. Here we go. I can get to them. All right. Yeah, I got them. So these are some questions that I got from moderator Pavel. I'd provide the answers to these up front. Thing is, I think they're in Markdown, so I need to run through them and make sure that they convert the quotes. What is it meant to do? First off, we want to understand how intelligence works in the brain. We have a dual mission. It's always been understand how intelligence works in the mammalian neocortex and implement software and using those principles. So has never changed. So that's the first question I'm about to answer. I'm just trying to get this formatted properly. Yeah, let's do this. Should I put them? I'll put one in each thread. How about that? So this other notebook. I've got it saved. All right. That worked. Okay. There's the first one. What does meant to do? So there it is. We're trying to understand how intelligence works in the brain. We're not even, focused on creating software applications. We're just trying to figure out how it works and write that part in software, write the algorithms in software. Okay, let me go to the next one. How is HTM different from deep learning? So let's do this. Primary difference is the neuron model. We use a neuron model that's a lot more realistic than the standard point neuron and ANNs. So at the core, it's like the primary component is different. It's much more complex. It has different areas where it can connect to other neurons, distal versus proximal versus apical. Those all play different roles in communication between neurons in the brain. So HTM is a theory of how intelligence works, not like we continue to research and add more to it. Includes the most recent neuroscience research, while current ANN techniques today are still, I think, trying to do as much as possible if they can with this older neuron model that I believe is too simple to produce strong AI. So there's another answer. 2 down. What is a brief history? Oh, this is going to be nice. Brief history of Numenta and HTM. It just so happens I made a silly video about this. Feel free to watch. I have to go my narcissism and see how there's 10 people watching. Thanks for watching, you guys. Here. All right, let me move on. How does it work? All right, that's a good question. So regarding HTM, how does it work? HTM. Can you give us a high overview of its components? So yes, I'm doing it. There's 3 main concepts that I always try and teach people that they have to understand about HTM to get a sense about how it works. Sparse distributed representations, spatial pooling, and temporal memory. And that's currently what we have implemented in software. That there's still more to HTM theory than these 3 components, but these things are the first things you need to figure out how it works. If you can understand that, you can move on. Additionally, we are researching theories of how more circuits within a region of cortex perform sensory motor inference and allocentric object representation. So even within one layer of the hierarchy, we think there are object representations within cortical columns. So I did a complete overview of HTM and discussed all the details of all these components in this HTM School series, which I'm linking here. So please watch that for a very basic, introduction from scratch. Is this working for you, Pavel? Okay. Another question. I have a personal project in AI. When should I consider using HTM? Okay. This is sort of a, wait, let me copied the wrong thing. All right, great. Our current HTM implement that we've written in software, it's called NuPic. That's Numenta's version of software, of the software. It implements our current HTM implementations. Let's say that, because there's more than one. There's NuPic, and there's HTM Java, which is very much a port of NuPic, and there's Comportex. I've seen some in JavaScript, just some in Rust. But for the most part, we don't have control over those. Those are community contributions to the HTM community. But typically, from what I see, they perform best when doing anomaly detection on streaming temporal data. That's what I'm going to write. That seems to be our sweet spot. So if you have temporally streaming data, also another nice sweet spot is if you have this type of temporally moving streaming data for objects over time, either moving over time or sensing over time in the same place, then you have like a high velocity data stream. HTM might help you identify anomalies in these systems, or perhaps predict future values. Okay. Okay. I heard you guys are working on a sensory motor component. What would it be like? Could robots with HTM system on board grab things easily? Okay. See, I've heard this question before. Okay. So yes, we're working on a sensory motor component. Jeff Hawkins, our founder, and I had a conversation about this last month, and here is a link to a playlist where we talk about this research. And could robots with HTM systems on board grab things easily? So it's honestly, it's hard to say what this is going to be like when it's fully implemented in software. We're still working on how sensor location and like of the location of the sensor that's getting the input and movement are going to be represented in the models, because there has to be a movement signal that gets put back into the brain. So there's still some questions about exactly where that signal is coming from and what it contains or how it represents the data, but we do understand that it contains some type of allocentric location information about the object being sensed. Okay, but if you think about a robot, any way it can interact with its environment, but must be encoded somehow into binary representations. That's the input to the system. And that has to contain the semantics of its movement. So the need to include anything that would change the input to the sensors. Each robot would have, this is something I wrote like yesterday. Each robot would have different encodings for movement depending upon its ability, its methods of interaction. The thing is, we have to create, when we do have this sensory motor feature, we have to have an interface to defining movement somehow that's very flexible, but at the same time, not too flexible. I don't know. But anyway, at this point, we're just using simulation and virtual worlds and modeling these extremely simple movements. Everything is a bit up in the air until we lock down some of those details about like understanding where that location signal is coming from. All right, there's another answer. Okay. And if you're listening on YouTube, and you have a follow-up question, find the thread on the AMA and reply there. I'll come back around and look for comments when I get through these. Okay. What's the research process for a project like this? Do you read papers, dissect brains, and watch rats running around all day long? Well, I'm not on the research team. I'm not a research engineer, but I see them a lot. I know them, talk to them a lot, and they're always reading papers about the latest neuroscience and going to conferences, talking about lots of different papers. So we don't have like a wet lab or anything, so we're not doing experiments. We're not doing neuroscience experiments, but we are reading results of neuroscience experiments. So I would say the research engineers read, discuss, prototype things in software, and sort of repeat that process over and over. Okay. Let's see. I'm gonna skip that one. How does HTM adoption look like in the industry? Anything cool you want to brag about? Let's see. So our primary success stories has been Grok, which was a product we created with NuPic, our open source library, to do streaming anomaly detection on server analytics data from AWS CloudWatch. And so that was commercialized by another company, a partner of ours now, who is offering services around that product. So that's good. I think it's cool. It's a cool product. We still use it. Works pretty well to identify things going on our servers that we can't understand. And that uses a NuPic HTM implementation. So that's our main thing that we brag about. There's also Cortical IO. Look into, I'm just going to put the Cortical IO. they're doing some really cool stuff in the NLP space. All right. Format something. Okay. All right. This is a pretty detailed response. I think it'll work. How does one start with HTM? Like resources, tutorials, etc. So here is a bulleted list. I'll pop it in there. If you don't know anything about HTM, watch HTM School. There's an overview video, and then there's like 12 others that walk you through all the things, what I said, SDRs, spatial pooling, and temporal memory. If you're a programmer and you want to write your own HTM implementation, a lot of people find that the best way to learn how HTM works is to write it in code. So read this document I linked here called BAMI, Biological and Machine Intelligence. We're trying to make it sort of a living text. We're adding to it over time. We want it to fully represent the accurate portrayal of HTM theory at any point in time. So we'll be adding to this as we continue to evolve HTM. If you want to build an HTM application with an existing HTM implementation, which there's a link here to those implementations, I have a couple of things you can go. One is our NuPick Quick Start. NuPick is the Python version of HTM that Numenta has developed. And HTM Java is the Java version that one of our community members very gracefully ported into Java for us. And so I would recommend that as well. Let's see. And if you want to just discuss HTM with our community, go to our forum. It's a nice place. There's nice people there. Okay. I read Jeff's book on intelligence and found it interesting. So did I. What other literature should I read next? So the main thing I'm going to reference you to is this BAMI book again, Biological and Machine Intelligence. That'll walk you through it detailed. I mean, there's pseudocode in this and supplements of this, but you don't have to look at the pseudocode to understand the text. So if you're a programmer, you'll understand the pseudocode. Maybe it will help your understanding of it. But you don't have to be a programmer to understand this. Okay. Try this. Okay, it seems like HTM is geared towards Internet of Things. How does Numenta see IoT's future development? So I think IoT is a really interesting space because of the amount of data produced from individual sensor locations. In many ways, it's perfect for HTM because the data is temporal by nature and each sensor could provide, I'm going too fast here because I've already written this, but each one of these sensors could provide that proximal feed-forward input into some collection or structure of HTM networks. However, Numenta, we're not leaning towards IoT and development of HTM in any way. It just so happens that IoT is an applicable space because of the nature of the data creation. It's more aligned with the way human senses continually create data that's processed by the brain. Those are my words, and that's what I think it is. So I think we align with IoT because IoT sort of aligns with having sensory input. All right, I got one more thing. No, I don't. That was it. I'm not gonna do that one. All right, so now I'm going to go through the questions and answer them. You're probably all thinking that's what you should have done the first time. Okay, the HTM community. Let me go find this one so I can. Here it is. The HTM community largely stays separate from the mainstream deep learning community. Are there any mainstream deep learning ideas that you'd like more than others? Okay, so here's the thing you gotta understand. I never got into deep learning. That's not why I'm in this field. Most people interested in AI, so I was interested in AI, but most people interested in AI take computer science courses in college and they learn about ANNs and early on, and they're learning about deep learning and all the stuff that we've done over the past years. And I never learned any of that. I never did that. I'm not a computer scientist. You don't need the typical machine learning skill set to work on HTMs. So I'm coming from a completely different direction. For example, I mean, I think anyone can understand HTML theory and with some basic programming skills, software engineering skills, build HTML applications, even with just a basic knowledge of mathematics, software, and the brain. I mean, I know some of the math, but not all of it. I haven't taken Calc 2 or anything. So that's my answer. I don't know any of these things. I'm in this field because I'm interested in how the brain works and what intelligence is and how we might be able to create intelligent things. Okay, so here's a big one from No Cortex. All right, No Cortex. Let's see. I'm going to quote you and answer these one by one. I think I recognize this commenter from machine learning Reddit. Okay. So one by one here, and I wrote some pretty long answers for this one. 0 in the list. Why are there still leading figures in machine learning intelligence, and he gives some examples, have strong doubts on the future of HTML-derived implementations? Honestly, I don't know, because I haven't talked to any of those people about what their doubts are about HTML. So I don't really know. 1, any midterm plan to integrate HTML in very well-known commercial products? And he says not Grok or Cortical IO. So Numenta has no plans of creating HTML applications at this point. We're at our core, a research and development organization. We hope our discoveries in HTML theory will allow others to build interesting applications as the HTML implementations continue to evolve. Number 2, why has HTML had no success stories that fade away some of the doubts and people in the ML community have, like outperforming other solutions on Kaggle? Well, we're not attempting to solve competitions, and we're not trying to create these success stories directly. We hope that'll happen organically, but my company is not putting effort behind those endeavors. The only real place we're trying to put effort right now is just into research, because there's still so much more we don't know about how even parts of the cortex just within a region works. So there's still so much more to know. So we're focused on that. 3, what are the future plans to beautify the ugliest part of NuPic? So I don't know what is the ugliest part of NuPic. I've spent a lot of time the past few months creating much more complete API documentation, so maybe that helps. I'm linking to it in this comment. Hopefully this makes approaching the software less ugly for everyone. So I admit there's some ugly parts, but I think software that's been around longer than a few years is always going to have some ugly parts. Hopefully this makes it a little less ugly. I've also done a bunch of refactoring to standardize our code. That's ongoing. I'm making breaking changes, so we're trying to make it cleaner. On most platforms, you can still easily install with pip install NuPic. So we've made that a lot less ugly. That used to be sort of a process to install, and you can usually install pretty easily now. I assume maybe the ugly part is you're talking about, like, there's a Python and then there's a C++ extension involved or more. So this allows it. We need this. We are a research organization, remember. So we do prototypical implementations in Python, and then we do more longer-term implementations of algorithms in C++. It's good to have them both. We can compare their results, and then we can easily do quick prototypes in the Python world, and then make things really fast in the C++ world. And then users can choose to use one version of an algorithm or another for different parts of their application. So that might be a reason it's ugly. Let's see. We currently maintain both these repos, NuPic and NuPic Core. That's the Python and the C++. NuPic Core also contains Swig bindings to the Python, and it allows anyone to create language bindings of those core algorithms that are all in C++ to whatever language they want. So if you want a Ruby implementation of HTML, you could create language bindings for Ruby around NuPic Core or C++ code base. to allow people to build HTM systems in Ruby. Okay, 4, why do Menta seem to abuse neuroscience terminology without having benchmarked results? If you read white paper, you'll find a bunch of neuroscience terminology. This makes it hard to grasp HTM intuition. For instance, synaptic permanence values are just floating point numbers, and if they exceed a threshold, it's deemed to be connected. Do you think it's necessary to explain this as synaptic genesis? In fact, it is neuroscientifically debatable, and most importantly, does not help to understand. So you have to understand that all of our research comes from neuroscience. So it's hard not to use those terms, even though how we enact synaptogenesis is simple, and you can explain it just by saying its permanence values are just floating numbers and they exceed the threshold, it's connected. That's how we implement synaptogenesis. And yes, some of the but keep in mind, I'm trying to stick to the text a bit here. So some of the parts of this theory are still being debated in neuroscience communities, but keep in mind, we live in the realm of theoretical neuroscience. That's what we do. So I don't mind if some of our positions are controversial. And of course, why is the sine wave prediction demo not work as expected? So this example is more of a sample of using the NUPIC API. When I made this, it was a long time ago. And I was just trying to see what I could do with NUPIC. And so just doing this seems simple because everybody can understand a sine wave. It turns out NUPIC's not good, or this particular setup of HTM the temporal memory working on top of the spatial pooler with this data, the sine wave input, it's not good at predicting the next point in it. There's an explanation, and I'm posting this comment from our founder, Jeff Hawkins, about why. And remember when you read that to replace CLA with HTM, because we used to call this CLA. So there's, boom, ton of answers to you, No Cortex. Thanks for all your questions. Okay. Let's see. I need to find a new question. For those less familiar with HTM, how would you elaborate, classify the spatial scale method used in its hierarchy? So this is a little hard to answer. I think I understand what you're talking about, but I may be answering the wrong question, because when you say spatial scale method, and especially within the in reference to the hierarchy, I think what you're talking about is the fact that in higher nodes in the hierarchy are more stable, their representations are more stable and slower moving, because they're representing things like a more general idea of things than is happening down in lower levels. It's because lower levels are closer to the input from the sensors, and they end up identifying more finer grained objects, things like in the vision domain, like lines or curves or dots or some, simple little small recognizable things. As data transcends the hierarchy, it resolves to more general object representations that are held in memory for longer durations. As these higher level representations are persistent across changing spatiotemporal sensory input from these lower levels. I hope that makes sense. I think I am not a neuroscientist, okay? But I think that's an explanation of what you're asking. Okay. So I'm going to try and answer every question, even if I don't have an answer. So HTM, here it is. Does HTM theory or its common implementations discretely address the different time scales of adaptation, dorsal versus ventral stream? Again, he says this is more for the biomimetically oriented crowd. I sort of know what you're talking about, but I certainly don't know enough to answer this question. So I'm going to point you to our HTM theory forum. That's where people might exist that would be able to answer that question. I think it has to do with what and where pathways. So that would be sort of the newer research that we've been working on with sensory motor integration and two different cortical circuits. Okay, let me go on. Has the produce of Numenta, I probably meant to say something else, products. Has the products of Numenta supplied any predictions, insights into original treatment of psychiatric neurological conditions? No, but we haven't been trying that. So that's, so no, but I don't, but the thing is, I mean, because I know a lot now, I think about some of the basic algorithms that make up intelligence in the cortex. I look at some of these conditions in a way that I think I can understand what might be happening. So I think that there's potential for this theory to help those types of conditions, but we're not working on it. It would be cool if there was some type of health startup or something that was working on applying HTM theory to conditions like that. But, okay. What is the best parallel approach to scale HTM? Oops. Okay, so I'm gonna write, I don't have any experience with these approaches that the commenter left here, sorry. But I do know we've tried some other things. So I think that HTM would fit well in a system like Spark or Flink. There is an integration of HTM Java with Flink already. So you can integrate data streams. Flink, I think, is for streaming data. So we work great on streaming data. We're going to find data that we work great on at a much more high. There's a much higher likelihood of finding data that HTM in its current state works well upon if we're in streaming data. And Flink is a streaming data platform. So I'm talking too much now. Anyway, I'll mention Spark and Flink. We've also done some vertical scaling manually just by simply writing our models to disk if there's gaps in between data points, so they're not sitting there taking up a bunch of memory. But sorry, that's not the best answer. Between now and do you have any tips for a senior year mathematics student with a concentration in machine learning, data science? I like this question. Here we go. There we go. Okay. Do you have any tips for a senior year mathematics student with a concentration in machine learning, data science from a normal university who would like to be involved with artificial intelligence anyway, opposed to just business analytics and data science? So regardless, here's my advice. Regardless of whether you're a grad student or a high school dropout, I have the same advice for you if you want to get into artificial intelligence. Learn how to program well. Start now, write Python or JavaScript or anything. It doesn't really matter, but learn how to program. If you make yourself a good coder, you can take your career any direction you want. The power in being a programmer is being able to work in literally any field on the planet. I love being a programmer because I can go work in the space industry if I want to. And who knows, that sounds fun. Could go work in genetics. There's a lot of fun stuff you can do with programming. Okay, what is the best? Ooh, I love this question. What's the best HTM has done in a Kaggle competition? Very poorly, but I hate to make excuse for it. It wasn't. It was a community project. Numenta has never attempted a competition like this. I don't know. I don't want to say that. I don't want to put it down. It never really got off the ground. It never really got off the ground. It could have had potential, but it was a hard problem. It was a signal analysis problem. That's a hard problem. Okay. So, yeah, we're not doing great with Kaggle. Is the partnership, oh, I think this is like a 5-part question, but I have a bunch of answers. So, there we go. From Hot2. All right. Is the partnership with IBM bearing any fruit? No. They have not been interested in working with us after we put a blog post about, and we called Watson Classic AI. 2, are there any recent practical implementations using HTM in use? Something that my like flight path anomaly linked to that. I didn't know that project existed. Thank you for pointing that out. That was cool. I think I want to use it for something. Aside from Grok, as I mentioned earlier, no. Although we've had a lot of hackathons over the years, you can find some interesting ideas from these hackathons on YouTube, on our YouTube channel. So I'll link to a few of those. Okay, if not, have you approached any well-funded government agencies with an offer to set up such a system? No, because we're not interested in being a consulting agency, or we don't want to do HTM consulting. We want to focus on research and theory and prototypical implementations of theory. Why do you think some people in the machine learning community feel so threatened by Numenta's research breakthroughs? It seems like I can't read anything about Numenta without someone trying to troll in the comments. Yeah, that happens. Less now than it did before. So I think it's gotten a lot better. And even on this AMA, I only saw one nasty troll comment, and I think it got deleted. But I think it's because the machine learning community culture has a deep respect for peer-reviewed papers and mathematical proofs as a marker of reputability. And for a long time, HTM had neither. We do have some papers now at this point, but there's not really any mathematical proofs for us to perform. The majority of the machine learning community seems to have initially disregarded HTMs as a valid alternative to ANNs, I think because of the papers and the proof thing. And a lot of what we're doing now is sort of regarded as just slick marketing. But I can tell you, I mean, if you've seen the HTM School series, I mean, I'm not hiding anything in that. That's running NUPIC. I mean, you can see exactly what it's doing. We haven't been misleading about anything, so I don't understand some of their comments. But anyway, that's all. I'll talk about that. Oh yeah, there's one more paragraph. So I think what some of these people miss is that they don't understand we don't have the same goals as the machine learning community. Our mission is to understand how intelligence works and then make software that is intelligent in the same way that we understand it works in the brain. So we're working on a different problem. I think that's the main thing. All right. Another big question down. Which part of HTM theory is currently most likely incomplete and needs major work? Find this question. Which part? Yeah, there it is. Okay. Yeah, also assuming that no one knows how the brain really works. It's true. No one has a full theory explain how the brain works yet. And everything that we've done is focused on the neocortex. I mean, there's still a lot of interactions with other parts of the brain that we're not modeling at all. So I would say the biggest unsolved problem that I see in the current implementation is in sequence termination. This is something I was going to talk about in the next episode of HTM School if I ever get to it. But the temporal memory algorithm has no decent way of closing sequences as it's learning. So it relies on manual sequence termination. Like the program running the stream has to tell the HTM end sequence, end sequence, end sequence. So we don't understand how this closed sequence signal is created or used in the brain. I'm not a neuroscientist, remember, so I've had conversations with our research team about this, and I'm just kind of trying to convey the information that they gave me. So we can assume that this closed sequence signal might have something to do with attention, or but that's some faraway research topic. So we don't understand how temporal memory sequences close. Currently, they have to be manually reset in order to inform the TM that a sequence has ended and another may be beginning. Ideally, this would be done automatically. It might be a function of apical feedback. There's not enough research on the subject to know. So I would say that's the biggest incompleteness to the current implementation. Okay. Why hasn't Numenta tech gained more traction? Why hasn't Numenta tech gained more traction? How does it hold up in a head-to-head with mainstream deep learning approaches? All right. So it's hard. Let me start with this. We were discussing this recently on our forums. Here's a link to that. So we talk about that a little bit there. I have some reasons that I listed there. I don't want to just copy and paste here. But the thing is, let's talk about comparisons. It's usually hard to do a head-to-head comparison of mainstream deep learning approaches in HTM because HTM is a temporal memory model, a temporal sequence memory model currently. NuPic, the software implementation NuPic, and I'm going to write that, not HTM, because this is specifically about NuPic. NuPic is a temporal sequence memory model. Deep learning approaches typically do forms of spatial classification. NuPic does not perform well on spatial classification with its current implementation. However, we have identified some temporal sequence algorithms that can be more easily compared with NuPic. So we created the Numenta anomaly benchmark. There's something for you looking for benchmarks. What is the status of HTM with regards to neuroscience today? What is the status of HTM with regards to neuroscience today? This is a several-part question. All right. I work in computer. Oh, okay. What's the status of HTM with regards to neuroscience nowadays? I work in computational neuroscience, but I rarely see anything related to it. For example, HTMs refer to dendrites as independent processing subunits, which would require some sort of synapse clustering, but it's still debatable whether clustering exists in vivo. So Jeff and Subutai have relationships with quite a few neuroscientists, and I see them around the office sometimes. But in the area of neocortical theory, but the area of neocortical theory is still not mainstream. I don't know of any other organizations doing the type of theory work we're doing, even in the neuroscience arena. So even within neuroscience, there's not a whole lot of experiments being done with, well, there's not a whole lot of research being done in the areas that we're theorizing about. So the theory is a bit ahead of the neuroscience, I might say. But we're establishing some relationships with some neuroscientists and I hope that could influence future experimentation lab work. Is there some kind of universal approximation theorem for HTM? So I'm not familiar with that theorem. Like I said, that's a machine learning term, really. Remember, my background's not mainstream machine learning. I'm more interested in how the brain works than our current techniques. From like reading the Wikipedia page on universal approximation theorem, I think I would say yes. but I'm not certain that's true. Can you tell us about your area of work in Numenta and research interests? So I manage the open source community. All of our HTML implementations that Numenta has written are open source under the AGPL. So I create educational content, I write documentation, I create YouTube videos, I moderate our forums, I also fix bugs that I can, create build tooling. I make sure that the software is building and releasing properly, although a lot of this has been transferring to Scott Purdy, who's a friend and coworker. He's a manager of engineering, Numenta. And so kind of all the things. It's a good job. Jack of all trades, I guess. I'm not on the research team, but I am really interested in applications in video gaming in the future. So for example, here's a Minecraft hack I did where NewPick is performing live anomaly detection on my player's XYZ coordinates, which was kind of fun. But I want to do more stuff like that. I think the VR space is going to be really intriguing. And I think AI could bring a lot to entertainment and video gaming. Okay. I read somewhere that someone at Numenta was working on extending HTM. That's true. Some manner with respect to motor functions. Is this still one of your goals? And if so, can you give us some idea of whether or how subcortical structures and processes are accounted for in that work? Are control systems a target market? So first, yes, we believe that intelligence requires the ability to explore its environment. So sensory motor integration is required to do this. Our recent work is about incorporating the idea of cortical columns into HTM theory. So I talked a lot about this with Jeff in this video, which I'm posting again, so you can follow up there, or I mean, get more information there. Okay. So the question about Elixir and Erlang. I'm going to say simply no, it's not something we're working on, but I see potential. We do have an implementation in Clojure. If you like Clojure. It's not Numenta didn't write it, but a community member wrote it, and it looks cool. HTN has been around. This is like a several part question. So HTM has been around for a long time, since the publication of On Intelligence in 2004. What have been the most significant advances or changes in the theory at that time? There have been two major breakthroughs since On Intelligence. The first resulted in our current code base, which is on GitHub, and here's a link. And it's all about, well, mostly about spatial pooling and sequence memory. So our realization that SDRs were a required, like essential component of the theory of biological intelligence contributed to this breakthrough. And so this resulted in the current implementations of spatial pooling and temporal memory algorithms. The second major breakthrough that's happening right now, and I think there were breakthroughs before that, but yeah, but I don't remember. I wasn't here, so I'm telling you what I know. Second major breakthrough I think is going on right now, and it's about cortical columns within layers of cortex and how they operate together to do sensory motor integration. Let's call it inference and object recognition. You can read more about that here. I'm linking to a forum post, or watch the video series that I've already linked several times. Next question is, while parts of HTM theory seem compelling, it seems to be short on accomplishments that would validate the theory, especially in the messy perceptual domains where deep learning does so well. Are there any demonstrations of HTM being applied to non-toy examples such as speech or video recognition or prediction? If not, why? So yes, that's true. We're focusing on the theory, and we think applications based on the theory will arise as we continue our research and add more functionality to the core of HTM. We have found that working on applications at this point is a distraction from our core mission, which is to understand how intelligence works in the neocortex and implement software based on its principles. Okay. Okay, between now and when Numenta realizes strong general artificial intelligence, thank you for your vote of confidence. There it is. Just looking for the reply. Between now and when Numenta realizes strong general artificial intelligence, does Numenta have any intermediate milestones planned? And he mentions Go, Atari 2600, self-driving cars, virtual assistants, etc. So just a reminder, we're not a product company, so we don't have any plans of creating these products ourselves. After we released Nupic to open source, we did create some demo applications, and I'll link to those before refocusing on research again. This drummed up some interest in our technology, and one of those demos called Grok was commercialized and exists. I mentioned this a couple other posts too. Now, once we have sensory motor capabilities, it is likely we will again do a round of demo applications, maybe, I don't know, to show what might be possible with this in addition to HTM. But we can't tell, maybe, if it makes sense. But we're not going to be building products on this software. We want to remain a research and development company. Okay. And this is the last one I have before I go look at responses. Google is working with TensorFlow. Oh, he changed this question since I answered it. Google's working with TensorFlow, and they're making hardware accelerators for their algorithms. Is there anything like that in the future for Numenta? Google just announced their cloud tensor computing platform. Perhaps there's a way to implement Nupic on such hardware. No, I don't think so. Yeah, and I'll have to write this on the fly. HTM doesn't fit the TensorFlow model well because damn it, Scott just explained this to me. I'm just going to skip the TensorFlow. So I don't know enough about TensorFlow to answer that question. Some people may ask, are dolphins smart? We should instead be asking, in what way are dolphins smart compared to other machine learning algorithms? What do you see as some of the hurdles ahead? Okay, dolphins are smart. Dolphins are smart, seriously. Dolphins are... Study dolphin language next. Okay. Some people may ask, are dolphins smart? We should instead be asking what way dolphins are smart. Well, they do have a mammalian neocortex. I'll just leave it at that. Okay. I'm still at work, so I'm like monitoring HipChat. I'm not even sure if they know I'm doing this. Okay, so I think that's it. Now I'm going to go through and look for comments and perform further community interactions. All right. Actually, I'm going to take a break. So I'm going to pause this stream for maybe 10 minutes, and I'll be right back. Okay, I'm back. I don't know how much more I will have to do here. So I'm just going to look through replies, see if there are any questions I can answer. I hope this live stream was useful. I don't know. Okay. How long do AMAs usually run? There's one. And absent. So on the question of do we have any intermediate milestones planned on the way to AGI, and I explained that we're not a product company, so we're not trying to create products, but we probably will try and see what we can do once we have sensory motor capabilities. The original commenter said, then absent solving real world things with the code in HTM, how do you know that progress is being made by the research? Well, it's sort of theoretical. I mean, I can understand the new research on sensory motor stuff, and we have prototypes of it. Well, I don't want to say it's too theoretical. So we have written prototypes in our research repositories. I haven't, somebody has, with implementations of, let's just say, new network structures that implement sort of object recognition and an output layer as described. Implements object recognition from simulated somatic sensors. Bottom line is that I can see it working, but there is still a missing. There's still but we still need to identify where the allocentric location signal is coming from and what it entails. So basically, I know there's progress being made because I can see in our, like, we do weekly demos, and so I can see demos doing things that we couldn't do with previous theory. But I think there's still more work to do before we bring anything into, NUPIC. We've been working on a lot of papers, and so we've got a paper coming about this stuff that you saw in Jeff's YouTube video series, and what we've been talking about is the sensory motor inference theory extension to HTM. Okay, Jeff Hawkins, of course, mentions in many of his talks that higher order cognitive functions boil down to one learning algorithm in the neocortex. He also states this is a well-established piece of theory. Do I know what particular theory concept he's referring to? No, but it's sort of a common. I'm just going to say it's common knowledge in neuroscience fields. I guess I'll just say that. I'm not sure. I think that's it. I've tried to answer everything as honestly and transparently as possible. Not seeing it. Do I have to keep refreshing the page? Probably. Nice garage. Yeah. You don't have to, I won't move the curtain I have back there. And you'll get to see how nice it is. Does it work? As I understand. Okay, somebody has an add-on. Okay. As I understand it, this is from Dajte. As I understand it, HTM is a totally unsupervised learning theory, but doesn't actual intelligence need something like a reinforcement learning system? How can you get HTM to actually do something? And then he's got an add-on. So we need sensory motor integration to have it actually do something. That's what we're working on right now. As an add-on to the question, why actually focus on the neocortex? It seems like one of the least important parts for intelligence, since a large portion of animals get along without one. Similarly, you can carve big chunks of the neocortex out, for example, in a lobotomy, and the person may even still be relatively normal, but damage something like the thalamus or striatum, and the subject is basically dead. Well, we're not. So it's not about life, life, death. So this is a complicated question. The neocortex is considered the seat of intelligence in your brain. It contains all your long-term memories and also, let's say, all your long-term memories, things you've learned about the world, how to throw a ball, etc. You can take chunks out of your. This is really interesting to you guys listening. You can take chunks out of your cortex and still live a normal life because of the distributed parallel. Well, it's more like this. Because of the distribution of knowledge throughout vertical sheet. When you think about a coffee cup, there are neurons continually firing all throughout your cortex. In the visual parts, the auditory parts, etc. That representation of a coffee cup exists literally everywhere throughout your cortex. If you remove a section, you might no longer know what a coffee cup feels like and held in your left hand. I don't know. I'm just making this up. But you'd still be intelligent. This fault tolerance makes the cortex even more intriguing as, let's leave it at that. Let's leave it at that. Okay. Does Moore's law help you in what you do? And are we comparing intelligence to our own? Moore's law doesn't really help. I don't think about Moore's law very often, but I think more important than Moore's law is hardware plasticity. We need hardware that can grow and degrade connections between components. And are we comparing intelligence to our own? Intelligence, everyone has their own definition. That's correct. Okay. Let's see. With AI and robots, it can only do what it is programmed to do, like Asimo. Do you think there will be a time when they start programming themselves? And what job will the programmers have? That's a good question. All right. One thing, this is my own opinion. This isn't something that like we discuss at Numento, okay, but this is my opinion. One thing that will be hard to implement in AI, no matter what the method, is creativity. By the way, this is Matt talking, not. By the way, I am speaking for myself, not particularly my company. This is my opinion. I think programming requires creativity. Creativity. So I don't think the important programming tasks will be snatched by AI anytime soon. Okay. All right. 64 comments, 68 comments. Half of those are probably mine. I'll run back through and see if there's any more. Okay. I think that's it. Yeah. I think that's it. Well, I'll come back and check and see if I can respond to any further comments then. I guess it can work like that. But thanks everybody for joining in and asking me a bunch of questions. I was happy to answer them, and it has been fun. And I'm just gonna let my moderator know I'm about to wrap it up. You must be watching. All right. Thanks a lot, everybody, for joining me for this AMA with me, Matt Taylor from Numenta. Take care.